write the vector v in the form ai plus bj, where v has a magnitude of 12 and the direction angle we'll call theta is pi over 6. Okay. Now, one final little recap from Friday. In your textbook, you won't see these little arrows on top of there. That's because they can boldface the letter itself. Okay, so when you see bold letters in a textbook, that represents vectors. But you can't really bold them when you're writing them out yourself. So to make sure you know it's a vector, we put that little line above it. I shouldn't say line, put that arrow above it. Okay? So we have all the information we need, and if we look at the prior whiteboard, we're going to use that information to write out the components of that vector. Okay? So let's go ahead and do that. So let's find the A components, or in other words, the X components of it. So I'm going to take the magnitude of our vector B multiplied by cosine of our direction angle. Okay? So that's going to be, let's see, they give me the magnitude is 12 times cosine of pi over 6. Okay. And we can see that this will be 12 multiplied by square root of 3 over 2, because that's what cosine of pi over 6 is. Don't forget the I. And this just becomes 6 square roots of 3. So visually, on the x-axis, you would go 6 square roots of 3 units to get to the x-coordinate of the x part of your vector there. Let's repeat it with the y value. So we'll call that b here. Same setup, just with sine. Okay. So our magnitude, our length of the vector is 12 times sine of pi over 6. Okay. And pi over 6 for sine is a half. So 12 times a half, which gives me 6. Okay. So putting it all together, we get 6 square root of 3i plus 6, and it'd be j. So there it is. Okay? So that's the, think of it as coordinates. That's the coordinates of where our vector is located, right here. Okay? And again, you could leave it like this. They did want it in i's and j's, but you could rewrite it without the i's and j's and just put the brackets on it. But again, they're still equivalent. So I kind of kept it up there for us so we can kind of see it. All right. Okay, any questions on that? Let's keep going. Let's try another example now. Find the magnitude and the direction angle, keeping in mind that it has to be 0, including 0, but up to 360. Or our vector S is going to be 3i minus 11j, and we're just going to round to 1 decimal place. So in this example, it's kind of like the reverse of this one. I had to find the components to make this up. Okay, now they're giving me those values. Now I got to work backwards to see if I can't find what's the length, the magnitude, like the full displacement of that vector, and what angle does it make with the x-axis. Okay? All right. So let's give it a shot. First, let's find the magnitude. That's easy to do. Okay, so the magnitude is just finding the distance from the origin to this guy. Okay? So the origin is 0, 0, so I don't have to worry about plugging those values in. So therefore, it's just going to be 3 squared plus negative 11 squared. Okay? I think in one of the very first examples we had values to subtract. Don't have to here. So we get square root of 130. So that's the magnitude of the length of the vector itself. Okay, let's check that off. We got the magnitude. Okay, the angle. It's not too bad. Let's go to this picture over here. So to find the angle, if I know the adjacent and opposite side, that sounds like a tangent, right? Okay, so we're going to use tangent to find that angle measurement. So let's do that. So tangent of our angle. Okay. And A over B, so A would be the 3 and B would be the negative 11. I'm sorry, B over A, because we're doing tangent. So let's take the inverse. Let's figure out what that angle measurement is going to be. Bless you. Okay, and we type it in, negative 74.7 degrees. Now, recap of inverses. So tangent gives you a result in quadrants 1 and 4. So this one's telling you you're in quadrant 4, but it's not within that range. So to get to quadrant 4, to where it's in that range, I'm going to have to add 360 to that. Okay? So my angle is actually going to be 285.2 degrees. Okay? So I'll put here, we have to add 360 to get to quadrant 4, but more importantly, we want to get there counterclockwise. Okay, this gave me an angle that was clockwise, and that's not what we want because it doesn't give me within there. All right. So we need one example where you had to find the components to get to the vector, and one that I gave you the components, but can you find the length of it and the angle it makes with the x-axis? All right. Any questions on that? Yes?
Point 3.
Point 3. Oh, yeah, that is point 3. Thank you. Appreciate that. Okay, so now we get those two. What I want to do next is throw some application your way. Okay, so I got 2 examples left to finalize this. So let's talk about some physics stuff. Bless you. So we have some forces with the magnitudes of, so for V, it was 80 newtons. And for vector U, 205 newtons. Okay. And they act on a hook. Now I am going to draw the picture for you. That's going to be given to you, the picture itself. Okay, so imagine a hook, and imagine like 2 pieces of rope. Okay, one pulling in this direction, one pulling in the other direction. And they're exhibiting these types of forces. 80 newtons of force, 205 newtons of force. Okay? Now, the angle between the 2 forces is 45 degrees. Our job is we want to find the direction and magnitude of what's called the resultant force. Okay. Well, let me word that correctly. Resultant of these 2 forces. And then we'll round to 2 decimal places. Now, if you do take a physics class, at least you have some knowledge on how to do something similar to this. So here's the picture, and again, this will be given to you. Okay, the last example, there won't be a picture. I'll show you how to draw that. So we got vector U, which is here, and we got vector V, which is over there, and my angle of 45 degrees. Okay, so there it is. And I guess, well, no, that's I draw, that's not too bad, I guess. Let's color it. Let's make it prominent. There we go. There's the hook, right there at the origin. We got two forces pulling on it. We get this force pulling over here, this force pulling over here. Now, because of that, I mean, logically, you can sit there and say, well, obviously, the hook's not going to go in both directions. We got to figure out where's the force of that hook going to go, right, when you're pulling like that. And we call that the resultant of those forces, okay? And wow, that is not how you spell resultant. I don't know if I ever caught that. You and Neil got switched around there, sorry. But anyway, so what's it going to be? So to find the resultant force, you're going to add these two forces together. Now, in the first part of the lesson, we talked about how to do that geometrically. So let me show you. So I'm going to take, and again, a couple ways of doing this, but I could take this guy and add it to this over here. I could take this vector, add it over here, okay? And that spot is that terminal point, that resting point of where my forces are pulling this hook at, okay? So that's the resultant force. We're going to call it R. So we got there by adding those two forces together, okay? So technically, and just to point this out to you, you wouldn't have these dotted lines when you're drawing it yourself, but they help you to figure out how to draw this more accurately. Okay, cool. Now, here's the issue. I don't know what V and U are. I know what the magnitudes are, but I need their components so I can find what R is, right? I gotta find where these, kind of like the coordinates, right? I gotta figure out where that's at. Okay, so let's figure out the components of V and U first, and then add the components together. Okay, and how we're gonna do that is what we did over here. Okay, break them up to X and Y values. So let's start with U. Okay, so we're gonna take the magnitude of it and multiply it by cosine and sine of theta. Okay. So let's see what that's going to give me. So the magnitude they give me is 205. Cosine, okay, so it's going to be 45 degrees. Oh, not 45 degrees. Wait a minute. What's the angle for U? It's 0, isn't it? It's on the x-axis there. So it's 0 degrees. Now, multiplying 205 by both of those, I know cosine of 0 is 1, so we just get 205. Sine of 0 is 0, and if I multiply by 205, I just get 0. Okay, so there's the components of U. So let's find the components of V. Doing the exact same thing. Same setup. Now we know what V is, the magnitude of it. It's going to be 80 newtons. So we're going to have 80 here. And then the angle to get to there is 45 degrees. Now I want you to be careful. I'll make note of this more when we do the last example. But it's always the angle you're making with the x-axis. We've been doing so many bearing problems. It was like the angle from the north and south line. You've got to have to rewire your brain to go back to what we've done originally. Okay. So we get 80 multiplied by, well, these are both square root of 2 over 2's. And for our final answer, we get 40 square root of 2, and then again 40 square root of 2. Okay? All right. Question so far. So we found the components. Now we can add those components together to find what R is. Perfect. And then once we have them, we can find the magnitude. So let me underline these. So we're going to add those together. So I'll put it over here. Okay, so it's going to be 205 plus the 40 square root of 2, 0 plus 40 square root of 2. Okay. And well, we get 205 plus 40 square root of 2, and then just 40 square root of 2. Okay, so there it is. There's the components of R. So now that we have its components, we can now find the length of it by using just pretty much this formula, right, from the origin to here. So because the origin's 0, 0, just like what I did over here, I don't have to do 3 minus 0, negative 11 minus 0. I can just go ahead and square and add them and take the square root. So let's do that. Okay, so we're going to have, try that again, 205 plus 40 squared root of 2 squared plus 40 squared root of 2 squared, and we'll take the square root of the whole thing. So I'm out of space. We'll finish on this board. So typing that in your calculator, you get 307.73 newtons. Okay, so that's how much force is going to be pulled upon in that direction. All right, last step, let's find the angle. So we're going to find this guy next. Okay, so it's not going to be 45 degrees, but we're going to figure out what is that angle, because 45 degrees is from this unit, vector u to vector v. So let's find it. So tangent, theta. Okay, now we know the components, so it'll be 40 square roots of 2, right? Yeah. Over the x value. And we do get 16.90 degrees. Okay, so that's the angle the direction I should say. If you were to unhook that hook from the ground or something, that's where it's being flung at. Okay, all right. So just to recap, what you would have to do, find the components of the individuals, add them together to find the components of the resultant force, and then use the same process of finding its magnitude, and then find the angle that it's going to make with the x-axis. Okay, now I want to do one more, and this time I'm going to do one with i's and j's in it, just to see how you would work with it, but it's not going to differ from this that much. Okay, so example. So we have a boat that travels 10 knots at a bearing west of north of 25 degrees in still water. It encounters a current moving due west at 3 knots. Our goal is to find the true speed, and we're going to do 1 decimal place. And the direction of the boat, which is pretty important. Okay, so if you have a current hitting a vessel, you want to know, well, what direction it's going to head in after it hits the vessel itself. All right, so this one's no picture. We got to draw a picture. But we've done bearing problems before, so that shouldn't be too bad. So let's draw my north, south, east, west lines. Okay. So let's see. Boat starts, so 25 degrees. So we're in this direction. So we'll put here 25 degrees. Okay. So it's not too far from that north line there. Okay. Then we have a west current, okay, and by 3 knots. So we want to figure out, where's the boat headed? Okay. So that's going to be, actually, let me do this. I did not give myself enough space. Let me redraw that, guys. Way too close to the edge of the board. There we go. this is the current. That is not horizontal. There we go. Okay, that's a little better. Sorry about that. A little too squished. So current moving due west by 3 knots. So here's what we're going to try and find. So this right here, which is in pink, okay, that is the direction of the boat now. Okay, by adding those two vectors together, that's what I want to find. Okay, where is it heading now? So I'm going to call that just, I don't think they didn't name anything. So we'll just call that vector B. Okay? So that's what we want to try and figure out here. So let's say the current, call it vector C, put like a little C there, just so we have some notation. Okay? And then we'll do this as, well, seems logical to say vector B. So I'll put a little subscript there for B. Perfect. All right, so just like the other one, bless you. Let's find the components and then add the components together, just like we did over here, okay? But in this case, what I'm gonna do is use I's and J's to do it, which, like I said, it's not gonna change how we approach this. Okay, so let's find the components of the boat when it's first starting out. So again, instead of me just showing the comparison, here I just had the vector form of it multiplied by this and I was finished. Here I just doing the same thing but just putting I's and J vectors in there. Okay, so let's see. What do they tell me? 10 knots, right? So 10 times cosine. Now here's where you want to be careful. Remember, it's the angle that it makes with the x-axis, not the north-south line. So from here to here, that's my angle theta, okay? That's what I want to plug in. So if this part's 25, that's 90, so I gotta combine them together. So the angle we're gonna be using is 115 degrees. So when you're doing these, please be careful in the angle you're gonna use, okay? Don't just use the angle that you wrote down. All right, so that is for the boat vector. So let's do the current vector now, okay? And again, what I'm gonna do, the reason why I didn't put the decimal answers in yet, I'm gonna take this, add it to this, and then give me a final result, okay, to 1 decimal place. So let's see, for this one, this will be even easier. Okay. So look at the angle. If it's horizontal, that's what, 0 degrees? So if we're doing 3 units times cosine of 0, and then 3 times sine of 0, well, you just get 3. So that was easy. Because again, it's a horizontal vector. So 0 degrees with that one. Okay, now that we have the components, we can add them together to figure out where the boat's headed. So I just call that normal vector B. So we're gonna have 10 cosine, 150 degrees I plus 3. Actually, I don't need those because we're using I's and J's. Plus, well, it'd just be 0, which is just gonna be 10 sine of 115 degrees J. I mean, if you want to put 0 there, you could, but don't need to. All right, plugging this in, calculator, we get 7.2, negative 7.2 I plus 9.1 J. Now here's a good sign to know you did something right. I'm in quadrant 2, so I should have a negative x component and a positive y component. If it didn't match the quadrant, then I did something wrong with the angle. Yes?
Why is the 3i positive?
Say it again.
If it's in quadrant 2, why would the 3i be positive? If it's going that way.
would.
Would the angle be 180?
Since it would be resting on the x-axis in quadrant 2, I would say, yeah, it would be 180. Which would make sense, would make it 3. Thank you. Appreciate that. Okay, now, let me double check something. So what did I say, 10 cosine. Okay. Let's still give me okay, so that's good. That's what I thought. Plus 3. Huh. I still get negative 7.2. So somehow, my brain was okay with the 180 part. But thank you for catching it though. So we still get negative 7.2. So that's still on track. All right. So we have this. Now to find the true speed, we got to find the magnitude of this guy. So let's go ahead and find the magnitude. So we're going to take negative 7.2 squared plus 9.1 squared. And we're going to round to 1 decimal place, so we get 11.6 knots for that guy. So that's the true speed of the boat. So that incorporates the current. So now the last thing is, where's it headed? Okay, so we got to find the entire angle. Use green for that one. So we're going to find this guy. Finish it up. Okay, so we're going to do tangent theta. Okay, plugging these numbers in, so 9.1 over negative 7.2. Okay, take the inverse to get to that value. Now, just like the other one, okay, we're going to get, because it is negative, it's going to yield me a quadrant 4. Okay, so that's where we're at. But again, I don't want to be in quadrant 4. I want to be in quadrant 2. So I'm not going to add 360 to this, because the last one I had to be in quadrant 4. What I'm going to add instead? Add 180 to it. So my theta measurement, the direction the boat's heading, is 128 degrees. So again, have to be careful with the inverse stuff. Know where you're at and know where you're going with that. All right, that, my friends, is vectors. It's a lot. And it's one of those things where we kind of just scratch the surface. There's more that we can do with it, but that's as far as this class covers. But yeah, any final questions? Guys are awesome.